friends. Hi, Screeny. I think I'll just give up. What? Real numbers, polynomials, and basically studies. All this isn't just my cup of tea. How are you going to survive in the future if you don't update yourself? I never thought of that. You know, Screeny, you at times really use your brain first and then talk. Well, I always use it, but it's you who realizes it only sometimes. Oh, shut up! You mean I talk first and then think? No, I mean you don't think at all. Oh, I'll see you and I'll show you how good I am at studies. Alright, so do you remember what we did in our last class? You mean recap? Yes, I mean recap. Polynomials?
Yeah, polynomials are algebraic expressions.
Degree of polynomials?
Yes, the highest value of x in the polynomials is called the degree of the polynomial.
Value of polynomials?
Yeah, the value of polynomial is given by minus b by a, that is minus the constant term upon the coefficient of x.
Plotting points?
On a graph paper, you learn how to plot a points.
Linear polynomials?
Yeah, linear polynomials with the degree 1. Linear polynomials graph is always a straight line.
See? I know. I remember everything that we did in our last class.
Excellent.
Ma'am, I did the entire recap. Now I'm ready to study more, even more than Screeny.
Yeah, good. Hi Screeny. Hi Kelsey. Hello my dear children. Today we are going to study something about quadratic polynomial. So we will understand the meaning of geometrical representation of quadratic polynomials on a graph paper. Let us understand this by taking an example, that is y is equal to x square minus 3x minus 4. We need to find out the values of the equation by taking sum of the values of x and finding the values of y. Our quadratic equation is y is equal to x square minus 3x minus 4. We take sum of the values of x like 0, put the value in the equation x square minus 3x minus 4. We get 0 square minus 3 in the bracket 0 minus 4, which gives you 0 minus 4. Answer is minus 4. So we get a point whose x coordinate is 0 and y coordinate is minus 4. Take second value, we take x is equal to 1. Placing 1 in the equation, we get 1 square minus 3 in the bracket 1 minus 4. 1 minus 3 minus 4. That gives you 1 minus 7. Answer is minus 6. So we get second coordinate 1 minus 6. Now we take third value, that is x is equal to 2. Putting the value of x as 2 in the equation x square minus 3x minus 4. We get 2 square minus 3 in the bracket 2 minus 4. 2 square is 4. 3 into 2 is 6. So we get 4 minus 6 minus 4, which gives you 4 minus 10. Answer is minus 6. So we get one more point, that is 2 minus 6. Take another value of x as 3. So by placing the value of 3 in the equation, we get 3 square minus 3 in the bracket 3 minus 4, which gives you 9 minus 9 minus 4, that is 0 minus 4, and answer is minus 4. So we get one more point, that is 3 minus 4. Now we take one more value, we take x as 4. By putting the value of x as 4 in the equation x square minus 3x minus 4, we get 4 square minus 3 into bracket 4 minus 4, which gives you 16 minus 12 minus 4 equals to 16 minus 16. Answer is 0. So we get one more point, that is 4, 0. Now putting the value of x as 5, again in the equation we get 5 square minus 3 into bracket 5 minus 4, which gives you 25 minus 15 minus 4 equals to 25 minus 19, which gives you 6, and the point is 5 and 6. We take some negative values now. We take x is equal to minus 1. So putting the value of x in the equation x square minus 3x minus 4, we take minus 1 into bracket square minus 3 minus 1 minus 4, which gives you 1 plus 3 minus 4, that is 4 minus 4 equals to 0. So the point we get is minus 1, 0. We take one more negative value, that is x is equal to minus 2. Again putting the value of x in the equation, we get minus 2 in the bracket whole square minus 3 into bracket minus 2 minus 4. Minus 2 square gives you 4, minus 3 into minus 2 gives you 6 minus 4. 6 plus 4 gives you 10 minus 4, answer is 6. So we get a point minus 2, 6. Now Kelsey, since we have got all the points, what is the next step to be done?
Ma'am, we put these values in a table.
Yeah, very good. So we need to format all these points in the form of a table, which gives you x, y, 0, minus 4, 1, minus 6, 2, minus 6, 3, minus 4, 4, 0, 5, 6, minus 1, 0, minus 2, 6. So children, let us plot all these numbers on the graph paper and see the shape what it gives us. So let us plot the points now. First point we plot is 0, minus 4. So this is the point, and we write here 0, minus 4. Second point is 1, minus 6. This is your 1, y-axis minus 6. So this is the point 1, minus 6. Third 2, again minus 6. 2, minus 6. So this is the point 2, minus 6. Next is 3, minus 4. 3, this is minus 4 here. Next is 4 and 0. So this is the point here, 4 and 0. Next comes 5 and 6. This is 5 here and 6 on the y-axis. The point is here, 5, 6. Now we take negative numbers minus 1 and 0. Minus 1, 0 comes here. Last point we take is minus 2, 6. Minus 2, and 6 here. So children, let us join this point now. Earlier for linear equation we have seen it's a straight line. But if you see the shape, it's not straight line, it's something like U shape. So let us join it. What is the shape of a graph called? It is called a parabola. So from the graph we have seen the shape. It is like a U shape which is called parabola. In fact, the quadratic polynomial ax square plus bx plus c, where a is not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upwards like U or open downwards like inverted U, depending on whether a is greater than 0 or a is less than 0. These curves are called parabolas. Also note that the curve which we have drawn on the graph paper intersects the axis on 2 points. The points are -1, 0 and 4, 0. Therefore, we can say that the quadratic polynomial had got 2 zeros. Yes children, thus we can say that zeros of quadratic polynomial ax square plus bx plus c, where a is not equal to 0, are precisely the x coordinates of the points where parabola is representing the equation y is equal to ax square plus bx plus c, which intersects x axis on 2 points. Now Kelsey, do you observe the shape of a graph we studied?
Yes, ma'am. It is U-shaped graph.
Yes, very good Kelsey. These U-shaped graphs are called parabola. It can be of two types, that is, it's open upwards in the U shape or it is open downwards like inverted U. So we study on these. There are three cases. Case 1, here the graph cuts x-axis at 2 points A and A dash. The x coordinates of A and A dash are the 2 zeros of the quadratic polynomial ax square plus bx plus c. Here again, in the case 1, the graph cuts at 2 points A and A dash. The x coordinates of A and A dash are 2 zeros of the polynomial ax square plus bx plus c. Now in this case, here we can see that graph cuts the x-axis at exactly 1 point, that is at 2 coincident points. The x coordinate of A is the only 0 for the quadratic polynomial ax square plus bx plus c. Here in this graph again we can see that it cuts the x-axis at 1 point A on the x-axis at 2 coincident points, but the shape of parabola is in the upward direction. The x coordinate of A is the only 0 for the quadratic polynomial ax square plus bx plus c. Here in this case we can see that the parabola is completely above the x-axis and it is not touching the x-axis at any point. So we can say that there is no zeros for this quadratic polynomial. Now in this case we have the shape of parabola in the form of inverted U, which is completely below the x-axis and not touching the x-axis at any points. So this quadratic equation has got no zero. So children, you have seen that geometrically a quadratic polynomial can have either two distinct zeros or two equal zeros or no zero. This also means that a polynomial of degree 2 can have at the most two zeros. Now, to understand these cases, children, let us see some of the graphs given. Look at the graphs. Each is the graph of y is equal to px, where px is a polynomial. For each of the cases, find the number of zeros of px. See graph number 1. Now, we need to find out the number of zeros. In the first graph, we see the curve is touching the x axis at one point. So, we can say that this graph has got 1 0. In graph number 2, we can see that it is inverted parabola touching the x axis at 1 and 2 points. So, we can say it has got 2 zeros. Graph number 3, it is somewhat different. We can say the shape of two parabolas and they cut the x axis at 1, 2 and 3 points. So, we can say that this polynomial has got 3 zeros. Now, in this case we can see that it is a straight line. So, it is a graph of linear equation which cuts the x axis at one point. So, we can say it has got only 1 0. Now, we can see here it is again a parabola cutting the x axis at one point. So, it has got 1 0. In the last graph, that is 6 number, in this graph we can say there is a combination of 1, 2 and 3 parabolas which cut the x axis at 1, 2, 3 and 4 points. That means it has got 4 zeros. In general, given a polynomial px of degree n, the graph of y is equal to px intersects the x axis at most n points. Therefore, a polynomial px of degree n has got at most n zeros. Yes, Kelsey, did you understand what I mean to say?
Yes, ma'am.
Now, Kelsey, I will make it little more easier. Now, children, we understand this in a simple language that the number of times the curve cuts the x axis, the polynomial will have same number of zeros. Now, Kelsey, will you answer some of the graphs? In the case 1, how many zeros are there?
1 0.
No, Kelsey, it is wrong. We are not to see the y axis, we have to see only the x axis. So, there is no zero in this graph. Now, we can see, children, here it is a straight line which does not cut the x axis at all. So, we can say this graph has got no zero. Second one?
1 0.
Correct. Now, we can see here the graph is a shape of inverted parabola and another one more parabola which cuts the x axis at one point. So, we can say that this graph has got 1 0. Third one?
3 zeros.
Very good. Now, we can see here again the shape of parabola and inverted parabola which cuts the x axis at 1, 2 and 3 points. That means the graph has got 3 zeros. Fourth one?
2 zeros.
Excellent. Now, here we can see a parabola cutting the x axis at 1 and 2 points. So, we can say the graph has got 2 zeros. Fifth one?
4 zeros.
Very nice, that means you understood. Now, we can observe the shape as parabola, second parabola, third parabola which touches the axis at 1, 2, 3 and 4 points. From this we can understand that the graph has got 4 zeros. 6 1.
5 zeros.
Oh, again you are wrong, Kelsey. You have to see only the curve intersects the x-axis. The shape is like it cuts the x-axis at 1, 2 and 3 points. So, the graph has got 3 zeros, not 5.
Yes, ma'am. So 3 zeros.
Yeah, very good. That means you understood now that the places where the curve cuts the x-axis has got that many number of zeros. So, Kelsey, what did we learn today? What is the shape of a graph called? It is called a parabola. In fact, the quadratic polynomial ax square plus bx plus c, where a is not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upwards like U or open downwards like inverted U, depending on whether a is greater than 0 or a is less than 0. These curves are called parabolas. Therefore, we can say that the quadratic polynomial had got 2 zeros. Here, the graph cuts x-axis at 2 points A and A dash. The x-coordinates of A and A dash are the 2 zeros of the quadratic polynomial ax square plus bx plus c. Now in this case, here we can see that graph cuts the x-axis at exactly 1 point, that is at 2 coincident points. The x coordinate of A is the only 0 for the quadratic polynomial ax square plus bx plus c. Here in this case we can see that the parabola is completely above the x-axis and it is not touching the x-axis at any point. So, we can say that there is no zeros for this quadratic polynomial. Given a polynomial px of degree n, the graph of y is equal to px intersects the x-axis at most n points. Therefore, a polynomial px of degree n has got at most n zeros. Okay children, bye bye. Bye Kelsey.
Bye, ma'am.